Okay, so now I'm going to talk about the rules for differentiation, not the formulas, and then I'm going to go back because some of the explanations they require chain rule. So the first rule is I don't know the name for this, but it's just put the ddx into what you want to differentiate if it has addition and subtraction, right? It's pretty rudimentary. Maybe I will write an example for this. Yeah, it's pretty self-explanatory. So let's say I have 2x minus 4x to the third power. Yes, something like this, right? And then I will just put this in, and this will be d dx 2x minus d dx 4x cubed. Okay, so I will do this a bit slower because this is the first question we're doing. So this is similar to ax, so I will just take the 2 out of this. Now for the one at the back, for this you would take the constant out because it has nothing to do with x, so this is just 4. And then when you differentiate the inside, you will take the power down, and then you minus 1 from the power, which is 2. And this will be 2 minus 12x squared. And that will be the tangent. That would be your derivative. Yes, it will be something like this. Next one is product rule. Okay, so in Chinese we have some ways to easily remember these, but since we are using English, you just have to remember them by eye instead of having some well, not idioms, but some phrases to help you remember. So good luck. When you differentiate something that is multiplied, and then you will just take one side out, for this is u, and then differentiate the other one, plus take the other one out and then differentiate this one. Now this only works when both sides have something that is relating to x. So let's say I have a question like 2x sine x or something like this. Yes, so we have two functions with the same variable. Does that make sense? Well, we have an x here, or we have 2x, but we can take this out. We have x here and we have sine x over here. So these are two things. So let's say this is u, this is v or something. The first step, we take this out. D dx x sine x. This is the first step. And now using the product rule on top, this will be 2. Okay, we take x and then we differentiate sine x, which is cosine x. This plus you take sine x out and then differentiate x, which is 1, and then you don't have to write that. And this is your answer. And that is how you use product rule, right? Maybe I'll do one more. Okay, d dx x cubed e x, yeah, something like this, right? So I'll zoom out so you can see the product rule. You would just take one side. For this one, it is x cubed, and then you differentiate the other one, which is ex, which is no change. This plus ex, and take 3 down, and then 3 minus 1 is 2. And you can simplify this further. So I would take x squared, and then ex out. This will be x plus 3. X plus 3. Yes. Okay. Now, you'll realize that whether you take the right side, which is the v or u first, it doesn't really matter because this is addition and it doesn't change anything, right? So whether you want to take the u out or the v out first, totally up to you. The second thing is you don't have to simplify in the AP test. So if you leave your answer like this, you still get full marks, right? So if you are not good at algebra or factorization like myself, it would be better to just leave your answer like this instead of going an extra step and trying to simplify or factorize things. Yes. Now, onto chain rule. There's a quotient rule, and we're supposed to learn that first, but I want to teach this first. Yes. So, chain rule is pretty simple. Well, this doesn't look simple, and I don't like this explanation, so I'm just going to skip it, right? Okay. So, let's say I have something like this, 3x plus 2, and then everything is to the power of 5, okay? And I have to differentiate this. Now, I don't know if you guys have learned binomial theorem because I didn't take algebra in the United States, and I took it in Hong Kong, which is a totally different system. So if you know binomial, then you know that you can expand this to 6 terms, I think. But we don't have time for that, obviously. So what we would do is use something called chain rule. So I would do this a little bit slower. Okay? So if you want to differentiate something like this, you can substitute this as u, right? And when I substitute something like this as u, then I could say du, and then I can put this in, which is u to the 5th power, and this I will times du dx. Okay, so that is basically how I want to do it, right? If I put u back here, it would be 3x plus 2. And this will be 3x plus 2 to the 5th power times d 3x plus 2 dx. Okay, so since the variable here and the variable here are the same, so I can just do it like normal differentiation. So this, take the 5 down, is 3x plus 2, and this 5 minus 1, which is 4. And then I differentiate the back, and this the constant turns into 0, and then it's just be the slope, so this will be times 3. And then the answer would be 15, and then times 3x plus 2 to the 4th power. So that is basically how chain rule works. Right? It's not that confusing, right? If you use this one, you don't know what is u, you don't know what you're talking about. And what you're trying to do is just turn whatever's inside into something else. Or you can substitute x and then put this inside. And you just look at the steps and then you kind of know how it works. So let's just do another question. Oh yeah, I should probably say that I'm making all of these questions up, because you just need to know how to do this, and you won't really find any actual questions on the AP test that are solely differentiation. Yeah, they will. You need to know how to do this when you get into application, but it's only for application. So let's say I will use the same thing, 3x plus 2, and then I root this or something, and then I put cosine here, and then this is 2 is this squared, and then times, I don't know, 7x cubed, something like this. Very confusing, but it's okay. You have to relax. So I will just try to differentiate this, okay? So how to do chain rule? First step you realize is that the 7 is just a constant, so we can just take this out, right? And d dx, the inside, which is x cubed cosine root 3x plus 2 and this squared. And you can just differentiate this afterwards. So now I will try to demonstrate how to actually use chain rule in the exam. You'll realize that this is the product rule, so maybe this is not that good of an example to use. It's good. I'll just delete this. So now we don't have a product rule to do, just chain rule. d dx. Okay, so the first thing we would do is just look at what is on the outside, and for this question the outside would be 2, right? So we take the 2 down, and then we would rewrite the inside. Yes, so you just use the power rule, take the 2 down, and then cosine root 3x plus 2. And this to the power of 1, which is insignificant. Okay, and then now that I have dealt with the 2, I will just erase this. Erase it, yes. And now we're left with cosine. So cosine becomes a negative sign. And then just put everything that is inside like this. So now we've dealt with the cosine, we can just erase the cosine. Now we have to deal with the thing that is on the outside the most, which is the square root. So this we just use the power rule, and this will be 1 over 2, and then it will be 3x plus 2, and to the negative 1/2 power. Now we've dealt with this, and now it's just the most inside part, which is 3x plus 2, and this is just ends up with 3. And then I can erase everything. Right? It looks confusing, but if you just learn to go from the outside to the inside, then that's basically chain rule. Okay? No fancy notations, it's just the process of how to do it. I will not factorize this because it is too hard. Yeah, that's basically chain rule. Skip. Next one is quotient rule. Now, do you actually need to use quotient rule? No. You can skip quotient rule if you want to, but it is just a faster way to do division when you see when you have to do ddx of it. So it's basically it. It is you use the bottom, you take the bottom out and then d the top one, minus you take the top one out and then you d the bottom one here, and then it's just bottom squared. So if you don't want to remember an extra formula, then you don't have to. And so let's say if you see something like 3x, I have to make sure that you can factorize this, 3x plus 2 over x, okay, something like this, right? If you want to differentiate this, then it will just be take the bottom, and then this 3x is minus, and then the top, which is 3x minus 2, and then differentiate the bottom, which is 1, doesn't matter, and then it's just bottom squared. So this one would be 3x minus 3x is 3x minus 3x cancels out, and then this will be 2 x squared. Yes, so that is how you use quotient rule. The other way to do this, right, so I'll use another color, is to use product rule. This normal, and then this is x in negative 1 power. I did nothing, right? So the index of this is when you bring this back, when you bring the the x backup is -1. So technically using this, you can just do the same steps but use product rule instead. So you could take this and then differentiate the left part, and with this we get -1, and then x minus the index -1. Take this again, and then this will just be 3. Okay, and now you just have to multiply everything back. This will be 2 minus 3x, and then x squared. This will be 3x, and then you times x to both sides, you would get 2 minus 3x plus 3x, and this x squared, and then you will end up with the same answer. Now, in the exam that I trained in, which is the DSC exam, you have to simplify. So technically, this will the quotient rule will be more efficient, right? Because you don't have to do you don't have to factor the you don't have to combine the fractions together. But since you don't have to do a simplification in the AP test, then there could be a reason to use product rule and the quotient rule. Product rule or the quotient rule, right? So if you don't want to remember this, you can just use this and then end up with an answer looking like this or like this. It's okay, right? You don't have to do this part. So it's just do what you want.